Hello, this is the TI84 guy. I'm back with hopefully this will be a quick video. I'm going to do a video on the question of the day that from the SAT question of the day from June 22nd, which was yesterday. I didn't have an opportunity to actually create the video yesterday, but when I looked at the question, I thought it was a good question that I wanted to do. So I'm going to go ahead and do it today. So as you can see on my iPad, the date was yesterday, and the other thing that's important about this is that it occurs in the calculator per minute section. That's key. So if you have a graphing calculator, we're going to be using it. All right, so let's go to the question. All right, so here's the question. You have two equations here, and they want you to find, they said if x1, y1, and x2, y2 are two distinct solutions to the system of equations shown above, what is the sum? What's the sum? So we have to find the solutions to this system of equations, and they're saying that there's two, and we're going to find the sum of that. So here's how I would do it. Remember, in one of my old videos, just my most recent videos, I said that it's really good to be able to use your graphing calculator to solve equations. So, and the test for that is if you see an equal sign with one variable, you can always use your graphing calculator on the SAT or ACT to solve it. So here's what I'm going to do. So first thing, I'm going to take this equation. Let's make it blue. I'm going to take this equation and I'm going to substitute it in here, and I'm going to substitute it in here. So here's what it's going to look like. It's going to be 2x squared. So I'm taking this and substituting it in there. And then I'm going to take it and substitute it in here. So, and that's going to be equal to 3 times 1 minus x. Now, here's the things that we're looking for. It has an equal sign and it has one variable, right? So we can use our graphing calculator. And remember from my last video, it's y1, y2. So what we're going to do is we're going to go to the graphing calculator. We're going to enter the left-hand side into y1, the right-hand side into y2. Okay, and I'm going to include the link to my video where I actually go through how to use your graphing calculator in a little bit more detail. But now let's just keep moving. So here are the answer choices. We've got a negative 1/4, positive 1/4, 1, and a negative 1. If you look at this, it's always important if you're using your graphing calculator to find the minimum and the maximum, because your window has to be large enough to handle the smallest and the largest. So the minimum is a negative 1, the maximum is a positive 1, but that should be fine. So now what I'm going to do is I am actually going to share my calculator now and show you exactly what I want you to do. So here, from here you would go to y equals, because that's where you graph, and we're going to put in parentheses 2x squared. And then we're going to put in minus 2x. And then we're going to go down to y2, and we're going to put 3 times 1 minus x. Now, some people who aren't familiar with this process might say, well, what happened to the equal sign? Well, the equal sign is going to be where these two graphs intersect. That's what the equal means. When you graph something, it means where these two graphs intersect. And to me, it's easier to look at a picture and see where two lines are intersecting than to try to do it algebraically. So now that we got this, let's just graph it. All right, so here's one of the intersections. Here's the other intersection. All we need to do is find the x values and then subtract or add them. So here, so let's do this. So what we're going to do to find an intersection, we go second, trace, option 5 for intersect, and then we press enter 3 times. 1, 2, 3. So it went to this one, to the right, 0.75. And it always tries to find, if there's more than one intersection, the calculator will always try to go to the closer one. So if you want to go to a different one, you have to help it. So one of the intersections occurs at 0.75 cents. So let's do it again to find the other intersection. So second, trace, 5. Now, we want this intersection over here. So I'm going to arrow over to this and then I press enter 3 times. 1, 2, 3. All right, so the other intersection occurs at a -1. So now that I have that information, I can go back to my iPad. And so one of the intersections occurred at 0.75 plus, and the other intersection occurred at a -1. So 0.75 minus $1 is a negative 25 cents. So that would be choice 8. All right, that's it. This question is done. Now, I want you guys to see this. Okay, so here's the answer. We are correct. But here's what I want you guys to focus on. Over 36,000 people have attempted this question so far. Over 36,000, but only 44% have gotten it right. That's not very good. That's not very good at all. Now, my belief is that if more students would start to use their graphing calculators more strategically, there is absolutely no way that they miss these questions. If you learn how to use your graphing calculator, there's no way that you miss these kind of questions. So this would probably be considered an average to maybe medium difficulty problem, but there's no way that you guys miss this question if you know how to use your graphing calculator. Now, if this were in the non-calculator section, that's a different animal altogether. What I'm saying is when they're giving you the graphing calculator, my thing is you got to be able to use it. So let me review real quick what you need to do, what you need to be looking for. You're always looking for an equal sign and one variable. Equal sign and one variable. If you see that, you can use your graphing calculator to solve easily. That's the only 2 conditions that you need to be looking for, an equal sign and one variable. All right, guys, I hope you like this video. If you do, hit the like button. Also, it would be good if you would subscribe to my channel. This is the TI84 guy, and I'm going to sign off. I'll see you later. Stay safe.